Introduction to signed fractions. So fractions are great. Well, actually most people hate fractions. Fractions have been known to destroy people's lives, which we don't want it to do to your life, okay? So if you guys can get this stuff down, then when you see fractions, you don't feel that anxiety, that pressure. Sometimes it's kind of more like a madness, madness. But again, the nice thing about now we're starting in Module 3 is we're going to be using calculators, right? Now real quick, with fractions, it's important to remember that fractions are division, which we just talked about, right? A over B could also be written as A divided by B. And yeah, these would represent numbers, of course. So the parts of the fraction, we got a numerator, that's the top number, the bottom number is the denominator. And if we put it in terms that we looked at before, and one thing you guys will learn about math people is we use a lot of words to represent the same thing, and that makes us look a lot smarter than we actually are, okay? So that's kind of built into the process. I didn't make that rule up, but someone somewhere down the line did, okay? So whereas before we said it was a dividend, now we're saying it's a numerator. The divisor is now called the denominator, okay? And that would have been important for long division, but we're not using long division anymore because now that we're starting Module 3, we're using calculators. So just generally speaking, the numerator tells us how many of something, where the denominator tells us the size. Let me just bring up an example of this, okay? So the numerator tells us how many of something, the denominator tells us the size. This comes from, I'm going to use a food example. I like food a lot. So I'm going to say that we're going to say it's a pan of brownies. And I can't make you guys brownies, but, you know, if you want to make some, you feel good about it, okay? I would put chocolate chips in mine, but maybe not for you. So there's a pan of brownies. Well, let's say that this pan of brownies, let's say it was split in half. You know what? I'm going to split each of those pieces in half. And yeah, I'm not very good at cutting. That's not a very straight line. But it's splitting it in half. Let's say that all 4 of these pieces were the same size. Now, right now, I've split this pan of brownies up into what we would consider these as fourths, right? Like this is one piece out of 4 pieces. This is 1 piece out of 4 pieces. Also 1 piece out of 4, 1 piece out of 4. That's pretty good. So on this one, the denominator tells us the size. That's fourths in this case. And let's say that I was looking at, 3 of the pieces. Alright, so that's how many pieces am I looking at in that case? It's 3 pieces, and the 4 tells me that it's a fourth size of the pan of brownies. Okay, so it's a fourth of the pan. Again, if I split this into 5 pieces, then the 4 in green there, it's pulling up. This 4 in green would be a 5, which would represent fifths. So for this problem, identify the numerator and denominator of the following fraction. And this one is a little bit tricky. Alright, so if we were to look at this problem, just kind of immediately we would say, well, maybe the numerator is 9. And this, again, this is commonly what's put in there. You've got a numerator of 9 and a denominator of 27, right? Well, the question is, this negative here in the problem, this negative, well, where does that go? Does it go with the numerator or denominator? If you ever see a negative just kind of in front of the fraction, right there, then what you're going to want to do is always put it with the numerator. So in other words, that should be a negative 9 instead of a positive 9. Okay, so the denominator we generally always talk about as positive, unless for some reason they show the negative, and I don't think I remember seeing that in the homework. I do not remember that in the homework. If they showed the 27 specifically as negative, then they probably wouldn't show the negative out there in the front. So in other words, that would be gone. Okay. But as it was, the answer would be this way. Okay. So we got types of fractions. You got proper fractions. That's just where the denominator is bigger than the numerator. So that last problem that we just did. So negative 9 over 27. The 9 is the numerator. The 27 was the denominator. And 9, of course, is smaller than 27. Or you could say that the 27, the denominator, is bigger than the numerator. It's the same thing. So improper fractions. So improper is when the numerator is the bigger number. So an example of that would be where the numerator is bigger, right? So if I said the numerator was 3, then maybe the denominator could be 2. Right? 3 over 2. This would be an example of an improper fraction. Now we also consider, we're going to look at mixed numbers at the same time with fractions. So a mixed number is where the integer is followed by a proper fraction. So of course something like, I don't know, 7 and whatever, 3/5. Something like this, okay? Now when I say 7 and 3/5, that means that the 3/5 or the fractional part is also part of the integer, which means that if I made that 7 a negative, it's pulling up there, yeah, negative, then the 3/5 is also considered part of that negative, okay? So it's like if I were to say, well, let's compare negative 7 and 3/5 to just straight negative 7, right? Right. I would fill in this blank with less than, greater than, or equal to. The answer to that would be greater than. Wait, no, I apologize. I wrote that in incorrect. It's less than. Okay, negative 7 and 3/5, because it's more negative, so it's like you'd be owing more money than that negative 7, okay? So the negative 7 on the number line is farther to the right than the negative 7 and 3/5. So for this one, just real quick, determine if this fraction is proper, improper, or a mixed number. So, I mean, I know a lot of you guys know this pretty quick, but I know it's not a mixed number because it doesn't show a whole value right here, right? There should be some kind of number right there. And no, that doesn't mean hashtag. My generation, that meant number sign. So, it's just proper or improper. Now I can see in this case that the numerator, 17, is bigger than the denominator, which makes this an improper fraction. Alright, if the big rectangle represents one whole, what fraction of its area is shaded red? So this is kind of like the brownie example. I don't know anyone that has a pan like this, but again, we're going to be showing this as a fraction. So I would look and see, well, how many parts are shaded red? And again, we can count that. Well, 1, 2, 3, 4, 5 parts are shaded red. So that's how many there are. That's the numerator. And then the size of the pieces is just how many pieces the whole thing is split up into, right? So there's the 5, 6, 7, 8, 9 parts in the whole pan. So we would say the size of these pieces are 9th size pieces. So the fraction for this one, 5/9. Alright, so if one circle represents one whole, what fraction of its area is shaded, I guess that's cyan. Maybe I'm saying that wrong. But in any case, why don't you guys take 15 seconds and see if you can write the fraction of the area that's shaded cyan on this one, okay? Alright, hopefully you guys have that down. And it didn't say it wanted a mixed number. If you put it down for this one, I would say it's okay. I think on the homework, what they did want for this one is the improper fraction, right? Because we would look and see how many pieces are shaded, right? You got 1, 2, 3, 4, 5, 6, 7, 8. But not just those 8. We've also got these other 4 over here, right? So it's a total of 12. 12 pieces that are shaded this blue color. I would have said turquoise, but whatever. And then we would say, well, what are the size of the pieces? Well, we're not counting all all the pieces in both circles, the size of the piece is only based on one of these circles here, okay? So how many pieces make up one of these circles? Well, we saw when we counted that first one was 8, right? So this would be 12 parts, 12 pieces that are 8th size pieces. So 12/8 would be the fraction for this one. Now, this could be represented as a mixed number. And I suppose on the homework they would specify mixed number when they said, if they wanted it shown as a mixed number. So just real quick, a mixed number would show that we would have 1 whole pi. Should I not have said pi? I like pi a lot. But in any case, I've got 1 whole pi. And then from there, I've got these 4 pieces. And then this is 8th size pieces, right? So 1 4/8 would be the unsimplified mixed number. I think what they really wanted was this improper fraction right there. All right, this next one, write this mixed number as an improper fraction. You guys take a second and see if you feel like you can do it. Again, if you don't know how to do it, just try it out. But if you can't do it, or if you get it incorrect, that's okay. That's how we're going to learn, okay? It's a good learning strategy to get things incorrect to start with, because it'll help confirm things that we do. So the first method is, and again, hopefully you guys have some type of answer. What we know about this, remember, is that the whole thing is negative, including the 4/7, which means that whatever improper fraction I get, I need it to be negative. So I've got my fraction line in this case, and then just right there in the front there, I've got that negative with the fraction line right here, okay? And I'll just fill in the numerator and denominator as I go. Now, what this is telling us, and again, it's not important that you guys kind of show your work this way, but just right off the bat, I've got 30 whole, like if we're to look at that in terms of pies, right? 30 whole pies, which are divided into 7ths, right? So just from those 30 full pies, I would say I got 30 groups of 7. So 30 times 7 is going to tell me how many pieces I get from the 30 full pies, right? So multiplying that out, again, I would just put that in the calculator. So 30 times 7, again, it's going to save us a little bit of time. And also the calculator is a lot better at doing the work in its head than I am. So that would have been 210 pieces. Now that would have been great if there was only 30 pies, but then there's also kind of some left over, right? We got these extra 4 pieces. So from there, I'm going to take the 210 and add the 4. Again, I'm just going to put that in my calculator. So I'm going to take that, add 4. So and on my calculator, notice I just pushed plus 4, and then it took the previous answer, which was 210, and then added the 4. So I push equals, and I get 214. Not everyone needs a calculator for that particular calculation, but again, hopefully it's a little helpful for you guys. So that tells me how many total pieces there were of pi, if this was pi, that there would be. There was 214 pieces. Now again, we've already shown this is negative. And how big are the pieces? Well, they're all the same size. They're all in 7ths. So I just make this 214 7ths. That is negative, of course. So that was our first strategy. The second strategy, and I like this one. I like this strategy quite a bit. It's the calculator strategy. So on this one, write the improper fraction as a mixed number. So let's go and do this one. And again, I know the mixed number, whatever it is, it's going to be negative, okay? And we do want to focus on the signed fraction, so we're looking at negatives for the most part in this lesson. Well, the whole unit for that matter. Now, if I were to do this longhand, I would say, well, I'm going to take the 47, that's the numerator, and I'm going to divide it by 9. And I'm using long division here. So for long division, I'd say, well, 9 doesn't go into 4 in the tens position. So I'd look at the whole 47. How many times does 9 go into 47? Bam, it's 5 times. 5 times 9 is 45. So when I subtract that, I get 2 remaining. So right away, I know it's a negative 5 right now. And then to fill in the fraction, I had this 2 remaining down here. So that's my numerator, because I had 2 parts remaining. And then we just asked, well, how big were the pieces? Well, they were 9ths, right? So I got a 9 right there. And this would be the answer for that one. Now again, that took some time, and it wasn't even that much time, but the calculator would have done this for us, okay? So here's our first word problem, I guess, here. If you only have a 1/4 cup measuring cup, and a recipe calls for 8 3/4 cups of flour, how many 1/4 cups would you need to use? There's going to be a lot of them. So there's a few ways to look at this one, you guys. Is the 8 3/4 is already split into 4th measurements, okay? And the 4th cup is already in, of course, a 4th measurement. So we could look at this a couple ways, and we'll do it both ways, and we'll use the calculator to help us. But the 8 full cups, okay, how many 4th cups would I need to make the 8 full cups? Well, I need 4 per cup, right? So because 4 of these 4ths is going to make 1 full cup, but I need 8 full cups. So I would just take 8 times 4, which is 32, and that's 32 scoops of the 4th cup measurement. Now that's just to make the 8 cups, but I also need 3 more of the 4ths to make that 3/4. So I need to add that 3 right there, which would mean that it would be 35 of those scoops. Okay, so I would even just label this as scoops. One of the problems we get with 35 4th cups like this one is it now looks like a mixed number. Okay, so I don't recommend writing it like that one. You could just write 35 scoops. You could say 35 scoops of the 4th cup, and that's fine as well. Now, hopefully some of you guys recognize that strategy right there. This was 8 3/4. And this one works out really nice because it was already in 4ths. But what we just did right there is what we consider cycle method, right? Where you do 8 times 4 is 32, and then add the numerator to get what would be the mixed number for this one, which would be 35/4. Okay, so 35 of these 4th cup measuring cups, or 35 scoops, which is what the fraction is communicating as well. 35 scoops of 4th size measuring cups. And that equals 8 3/4. But again, if we were to use a calculator, that would work as well. All right, when putting values on a number line, what you want to do is kind of look at, and the 7/3, we're going to have to figure that one out. But see how, like if I were to zoom in on this right here, right? I can see that in between each of the whole values, or integers, like 0 and 1, -1 right here, I see 3 marks. That doesn't mean it's split up into thirds, because how many of the pieces make up a whole? Well, that's 1, 2, 3, and 4. So even though I see 3 marks, it's really split up into 4 parts on this one, okay? So in other words, like if I were to look at this part right here, that would be considered -1/4. And then the next part would be considered -2/4. Most people would like to see that as -1/2 though. And then this one right here would be -3 parts out of the 4. And then of course the -1 would be -4 out of 4 parts. Okay? But of course we're just simplifying it, showing it as -1. Like -1 3/4, we'll put this one in green. Make that a little bit better. There we go. -1 is right here, and then another 3/4. So there's 1/4, 2/4, 3/4. So this part right here would be considered -1 and 3/4. Now when you guys do this on the homework, you just put in a dot right there, or a point. That works. Now this next part is 1/2, and each of these is split up into 4ths. Each of these marks. So like this one right here would be considered 1/4 again. This one would be 2/4, which as a fraction would show is just 1 out of 2, right? Because this would be 1 part, that would be 2 parts. So it's like I split it up into 2 separate parts. So this right here, this line would represent, 1/2. See if I can clean that up a little bit. Right now, 7/3. So I can't use any of the marks on the lines for 7/3. Now, I mean, I could use them to estimate, which would almost be okay, but we should be able to just put 7/3 directly on this number line. So in thirds, like, I just need to go in and split up each of these into thirds, right? So like, I split between 0 and 1 up into thirds, right? So I need 2 marks between each of the values, but I need 7 of these thirds, right? So that would be 0/3, 1/3, 2/3, 3/3, 4/3, 5/3, 6/3. So I need these ones split up in as well. So 2 was 6/3. Next would be 7/3. That would be right there. 7/3. But again, you're just going to be putting a point on that line on the homework. So I kind of had to create my own lines for this one. On the homework, I don't believe you have to do that, though. Alright, so identify the fractions represented by A and B on this number line. So we just need to figure out how many, or what the size of the pieces are, I guess, first. That's what I would do anyways. So I'm looking at A right there. We'll put A. And again, we're going to be showing this as a fraction. So between 0 and 1, how many pieces are there? Well, there's this 1, 2, 3, 4, 5. So I can see that it's split up into fifths. And the A was the fourth piece on that, right? Because we had the 1, 2, 3, then that's the fourth piece. So that'd be like 4 pieces out of 5, or 4 fifth-size pieces. And that was positive because it's to the right of 0. B, on the other hand, is to the left of 0, so whatever it is, I know it's negative. And again, we should be showing this as a fraction. So it's negative, and these are also split up into 5 equal pieces, so I know I'm dealing with fifths. For B, I just need to know how many there are. That's 1, 2 right there. So that would be considered negative 2 fifths.